Welcome to Homework Lib.
So over here we're asked to calculate the delta G of the reaction and the value for Kc for the following transformation. We're going to have iron as solid plus copper to plus in aqueous medium, which is going to be in equilibrium with iron to plus in aqueous medium plus copper as a solid. So in this case, you can use two different approaches. One is going to be employing the delta G's of formation, and the other one is going to be employing the reduction potentials. So for this case, I'm going to employ the delta G's of formations. In the case that the appendix mentioned in the question is referring to a standard reduction potentials, please mention it in another question. So in this case, the delta G of formation for the different compounds that we're going to get are going to be for iron to plus and for copper to plus are going to be equal to 64.98 kilojoules per mole. I'm taking these values from Overby and Chang's 13th edition book. For iron to plus, it is going to be equal to minus 84.9 kilojoules per mole, and the values for copper as a solid and for iron as a solid for both of them is going to be equal to 0, since there are going to be substances under a standard state. So with this we can proceed with our calculations. The delta G of the reaction would be equal to the delta G of formation of iron to plus minus the delta G of formation of copper to plus in aqueous medium. In this case, I'm going to make the value for copper solid and iron solid, since both of them are going to be equal to 0. So we're going to end up with minus 84.9 kilojoules per mole minus 64.98 kilojoules per mole, giving us a total value of minus 149.88 kilojoules per mole as delta G for the reaction. With this, we can now calculate the equilibrium constant. Remember that delta G standard is going to be equal to minus RT logarithm of the equilibrium constant. Thus, we can calculate directly the Kc as the exponential of minus delta G standard divided by RT. This is going to become the exponential. We're going to transform the value of delta G directly into joules per mole by multiplying by 1000. So we're going to have minus 149,880 joules per mole divided by the value for R, which is 8.3145 joule per mole Kelvin, times the temperature under standard conditions, which is 298 Kelvin. Let's say this square parenthesis. And the result for my equilibrium constant would be equal to E to the 60.491 approximately, or equal to 1.866 times 10 to the 26. So this is going to be a very spontaneous reaction, and as you can see from the values for delta G of the reaction, and the equilibrium is going to be shifted in a quantitative way towards the products. And with that, it would be all. Thank you very much, and have a good one.